bit tough to do, as you can imagine. We're going to cover a fairly extensive program, and hopefully in a reasonable amount of time. And so if you have questions, ask them where we are. I'll try to answer you verbally, answer you. But on the other side of the coin, there is a sort of rhythm to the presentation that I'm going to have a little hard time deviating from. So we'll see how that goes, okay? Like I say, we're both in this together. All right, so my name is Doug Paradis. Most of you guys have met me. We're going to start to talk about KiCAD, which is a free schematic capture to PCB layout program that was developed by a gentleman in France. It's totally free and unlimited. There are people probably are familiar with Eagle. This would be basically could be a competitor to that. This is a slightly different model, but I think you're going to enjoy this. Okay. All right. So today's purpose is fourfold. I want to provide you some insight into the program, how it's organized. 2, I want to show you the typical project flow. 3, I want to overcome the where to start learning curve that everybody has with a new program. And then I'd like to leave you with some reference material that you could use later. And I want to do it all before you go to sleep. So with that, we'll start right in. Okay, clicking the icon. Well, this icon that you see in the top of the slide is the KiCAD icon. And when you click it, it brings up this program manager right here. And it turns out that this is what KiCAD is. KiCAD is this program manager. Underneath KiCAD, there are 5 different programs. The 3 that we're going to be covering is EE Schema, which is the schematic generation, CVPCB, which links the parts or the components to the footprint that will be on the PCB, and then the PCB layout. In addition to that, we're going to also talk about another program which is incorporated into KiCAD, which is called FreeRouter, which is a Java-based, web-based auto router that will work on not just KiCAD, but Eagle and all the other major programs. So that's the 4th part of this that we're going to be talking about.
Question, what are the 2 programs that you're not going to cover?
We're not going to talk about, and I didn't even pay them, Gerber View, which is a Gerber file viewer, which you would use if you were sending the PC board to a board shop. But since the focus of this is more you generating your own PCB, you don't really need the Gerber View. And then the second one is a little fun tool that they put in, which is a bitmap to component. And what it actually is used for is creating a logo that you can put on your board. I don't really know if it's ready for prime time. The logo I tried to create, I think I could probably do in another manner better. But it is kind of cool because it's built in, and it will, if you have a real simple logo, it would work real well. Okay?
One more question.
Sure.
Are you going to cover creation of new like schematic symbols and PCB footprints?
That's one of the nice things about KiCAD is it has a component editor, which is what the symbol that you put on a schematic, and it also has a footprint editor, which you can create the footprint. So like for example, let's say the standard resistor you don't like. I know Richard likes big pads. So you can modify or create a footprint that has big pads but has the spacing and the symbol that you want to use. Both of those programs in. We're going to talk about, we'll show the one for the schematics. I'm not sure we'll get to the second one. But they're both very easy to use, and they're both built into the program. And it makes it very flexible for a person who doesn't have access to tremendous libraries of parts. Okay. There also a tool that we'll touch on, but just very briefly. There is an equal to KiCAD library converter. So, all right. So here's the process flow overview. So you start off in PE schema, and that's where you create your PC, and there's three parts to that. It's creating the schematic, creating new parts, or parts are called components at this stage. And then also where you can run a rule check. Then the next step is the CVPCB, which is all it is it lists all the parts that you have over here down in a row, and then you associate a footprint to each part. Okay, so for example, let's say the footprint on a part uses round pads, but you like the rectangular, the ones that are like this. You can switch the footprint to that part. All right, so we'll go into that. Then from there, you go into PCB new, where you actually position the components on the part. There is an automatic tool to do it, but it's pretty much a footprint spreader, not necessarily a optimized placement of the parts. You can create new footprints. That's what you asked, Paul. You can set the layout design rules, which is important for later, and you can also run our layout check. Now, then, when you put the parts out there, all right, you haven't done any actual tracing. You haven't done any of the wiring of the parts together on the PCB yet. That's when you go to the auto router, and we will export a file from here to here, which will then auto route it for us, and then we'll bring that file back to here and touch it up a little bit and run our layout checks. Okay, here's our example project. I tried to keep in the line with building things for the Tiny Wanderer, which is the series demo tool. And so what this is, and I'll pass this around, is this board right here that uses a little IR sensor pair to essentially act as a tachometer. And we can, whoops. Where's the
R&D platform now?
Well, we might not see the demo.
Oh.
There we go.
Okay. You can see it's swirling around there, and there you see the output. Nice little kind of like squarey waves, and so it works pretty good. So the question was, can you do things through the wheel? The answer is yes, you can. Okay. Okay. All right. So one minor thing when you're setting up KiCAD, it's European, comes from Europe. So the default paper size that they use is one of the A4 or one of the drafting sizes, which you're not going to have on your home printer unless you're have much more better printers than I do. So one of the things you want to do right off is change the paper settings. This is the icon right here, and when you open that, you get the pager settings. You select user size, and then you put the size you have. Now, one of the things that I did find out on my HP printers, for some reason, I had to put 10.4 and 8.4 for it to work. On my brother printers, no problem. So I don't know where that quirk is.
Okay. It's a laser printer, that's the keep away. It won't print in the last quarter inch around the paper.
Okay. So what I'm saying is if the preview will give you what you want to see. So if you do the preview and it doesn't show the whole board, the whole border all the way around, knock these down a little bit until you do the preview and you see the whole board on it. Okay? Just a little tip you're going to run into. Okay, now these are the absolute minimum gotta know key shortcuts. All right? The middle mouse is very important. You can use that to center the drawings on a cursor. These are very nice. I wish all programs did like this. You can, otherwise, if you go on in the drawing and wherever you click the center mouse, the whole screen is going to center to that click point. So if you want the center of the PCB to be the center of the screen, you click on the center of the PCB, and then even if it's off on the side, it'll jump to the middle and be in the center. Okay? If you roll the button, it'll zoom in or out. So it's very easy to get the size to fit your screen. If you hit the shift, it will move the whole screen vertically, and if you do it with the control button, it'll do it horizontally. You know. Okay. Keys. There's 4 absolutely need to know keys. If you hover over a part or a component or a footprint or a label and you hit M, you can now move it. If you hit R, whatever it is, it'll rotate. If you hit E, it'll take you and allow you to edit its value or whatever editing is allowed on the part. All right? Now, one of the things that people talk about this that they don't like about KiCAD is sometimes the screen leaves little bits of something that was there before. Okay, so like if you rotated, you might have a couple of pixels that didn't get cleaned up. You hit F3 and it cleans the screen up. Okay, so to me that's kind of like a false problem. I mean, there's other things that I would be more concerned about. Now, a nice feature in KiCAD, both in all of the versions of the program, is that if you go out to the preferences, they actually have a place that lists all the current keys. So you click on that, and it'll generate a window that tells you what all the keys are. So, very nice feature. Again, something I wish all programs did. Okay? Okay, now, next we're going to be talking about capturing the actual schematic. Now, in general, you've got to have kind of an idea of what you want to do. And in the ideal world, you probably roughed it out on a piece of paper, pretty much. You might not have all of the bypass capacitors, you might not have everything just the way you want, but you kind of got an idea of where you want to go. All right? If you know what you got, you can kind of count up. I've got like 15 resistors, and I got 16 capacitors, and I got 3 ICs or whatever. It makes it a little easier to do it like all the resistors at once, all the capacitors at once. It's just a little faster. Okay. Okay. So we're going to add the circuit we have, the one that we're going to use, that little sensor board. It's all within the standard devices in the library. So we don't really have to create anything for it. But we will create a device to show you how the component editor is what it is, how it works. And we'll move the parts around the schematic. We'll discuss this offline, a little bit about power ports and power flags. And then we'll wire the parts together on the schematic. And then we'll name some of the wires for the Netlist. If you don't name them, they get named by the program, which are not intuitive names. And then we'll annotate the schematic, and then we'll run the rule checker. Now, so if everything works right, guys, when I push this button, we're going to get a little view thing here. And See? Okay, here you go. So you click on the add a component. That's this one right here. So you're clicking on that. Now this is the component selection. Now don't be daunted by that large number. We're going to select by the browser. There's really two libraries that for most common stuff. One of them is the device library, which has all the things like resistors, capacitors, and NPN transistors, LEDs, all of those little common stuff. Okay, now that I have it in the history file, all I have to do is click and hit OK. Okay, boom. Sometimes I'm a little slow on the click. Okay, so there's 4 resistors in this circuit. Now I'm going to go up and I'm going to select the NPN transistor, put it in there, drop it in, click again. That brings this up. I'm going to select by this. So I'm going to put it into optical, put it in. Now these are all standard in the program, so there's no big, this type of circuit is really not that big a challenge, but since I don't want us to be here all day, we'll, here's an LED. Okay, and then I think is that it? Oh, okay, now we're going to switch the light, we're going to go up to the connector library. All right, and connectors are named connector dash, 1 dash 2 dash 3, and if they, so for 3, this is the standard connector that you saw over there. Okay. All right, and so there we go. We put all the parts. Okay, I don't think we go further on this one. Okay, you can move by standing on it and hitting M. And one of the problems that you can run into here is that you see the little R. If you were to actually hover over the R and hit M, it will actually move the label R somewhere. And you have to be a little careful on that. M, I said. Now you're using R to rotate. I just rotated that diode around. Okay. All right, so now you know how to put parts on. Let's see if I get this here. So now we're going to look. Now we're going to look at what does it take to edit a piece. Okay, we're going to pretend we have a part that we don't have a part for, or a component for. So now we're going to do that. Okay, so you select the component editor, and this is what it looks like. Now, if you're using an existing, you want to select a working library. So usually what I do is I have my DP_lib, which is my library for any part that I create, and I put it in there. So that would be my working library that I would have that has every part that I've created in the past. And I would put this new part that I'm making into it. Okay, so we're just going to create a new part. So now I'm just zooming up, and we named it voltage regulator. So the first thing you do is define the pins. You name the pin. Okay, give it the pin number. On this part, it happens to be number 2. You can have it coming out of any of the 4 directions. Now there's a whole bunch of options here. Since this happens to be a voltage regulator, that's a power input. If it was just a chip, it might be an input, an output, or a bi-directional. For example, a microprocessor chip, well, most of them are bi-directional. If it's a NAND gate, you'd have inputs and outputs. Okay. So I've created another one up the ground, and now we're going to create the output. It's pin 3, and it's the other direction, left, and it's a power output. Okay, click OK. I drag it to where I want it to be, drop it. Okay, now we're going to create the actual symbol. Now this one's real simple, it's just a square. All right, but you saw the MPN had a circle and lines and everything. You have these tools over on this side to create this component symbol. All right, that's ours. We're finished. Oh, well, I'm going to take, there's a value and a, I don't remember what they call this, but this is what will be used in the annotator later on. All right, so now I'm going to save this current one. You can see I didn't catch this on the first one. So I exported it to it, and I created it. You want to replace it, yeah. And okay, it says it won't be loaded in until you actually put it in. Otherwise, the library is created, but it's not in the project. So you have to go up and check library. And the first thing you do is come down here and have put in the search path. It's our search path. It's already in there. So now I got to go find that. And I think this was me being late at night, guys. So, but I eventually find this place where I'm at in my KiCAD tutorial page, and there it is. I click it, enter it. Okay, now got to go down here and hit the OK button. Oh, here I'm showing that it's actually in there now. It wasn't in there before. So it's in the libraries. Then I hit OK and save. And this, the example _1 is our project. Okay? So there we go. Let's see, what do I do now? Oh, in KiCAD, it saves it, in the editors, it saves it in RAM. So you actually have to export it out of the RAM into that's to keep you from doing something like writing over something you really didn't want to write. Okay, so you kind of have to do it twice. All right?
Question.
Sure.
What if you want to copy an existing symbol and...
You would go to the working library, okay, and you would select where the symbol was that you wanted to start with, and there's an icon there that's basically get component from working library. And you bring that out, okay, and then you edit it the way you want to have it, and then you have the option of exporting it or the option of creating a new library. Now there is one little difference. When you export it, it puts it in your project directory, which is what I just did. That's not necessarily what you want to do. You might want to create a new library and put it in where they store all their normal libraries. And that one you use to create a put component in new library icon. These long names are because I think it's translated into English from French. Okay? All right, so that would be how you would do it. The answer is yes. You can do, you're very manipulative. And you saw how simple it was to create a component. Okay? And now, the kicker. There is a web tool that even makes it simple. Okay, and we'll look at that at the end. Okay? So, now we'll go to wiring. So now we've got our components in there. You remember back where we were. You remember this? Now, I have moved the components around so that they're kind of making them easy to wire. If you remember before, I just had them kind of stacked on the screen. Well, here I've actually moved them where I would want to. So you select the wiring one. This one's the bus. If you had a bus, you would use this icon, which is kind of thick. If you're just using the individual wire, you use this one. And all you do is click and drag from node to node.
Is it a double click to finish the wire, or?
Yes, double click to finish the wire. And not thinking real careful, I think if you go from node to node, sometimes you have to double click to kind of like a double tap, to make sure you're stuck. Okay. Yeah, the wire, the way it bends around corners and stuff is very nice. You can hit enter and it will create a curve. Like right there, I hit enter, so it would go sideways. And I could hunt for this right spot, and it will go up and down with me. You don't have to be on a node. You can connect a wire to a wire, obviously. All right, now I'm using the, I'm going to actually label some of the wires for the Netlist. So I'm going to name this wire sensor, and I'm going to just stick it there. I'm going to name this one VCC. I'm going to stick it there. Okay, I'm going to go down here and name this one ground. I'm real creative with the names here, and let's look that. And just for grins, to show the rotation and move works, I'm going to stick one out here called. You see, I could have changed the orientation in the box, but all I did was hit hover and R. Okay. All right. So now, if you notice these things are all R. Well, that's not very useful. You know, we actually have values. So we're going to change them. So we use the select icon, which was the way up in the corner. I'll show you that. And you just go in there and change it. This is the select icon. So I hover, hit E. Now, see, there's a reference number and a value. We're changing the value right now, not the reference. And we'll talk about the reference in a second. So I'm just going to go in and change all of these. Bear with me. Now, I don't always go down and show you the OK box, but you kind of understand there's an OK thing down here. Okay. So anybody have any questions about this? This is pretty straightforward, right?
So it basically remembers what it was you were doing last, and so when you pick another object, that it knows that you're working on the value more.
Well, actually, by hovering over the R or otherwise in each, do you remember I brought that little U down and I didn't know what it was? That's the reference.
Right.
Okay, so that's the reference. So you have a value, which in the case, our case of that part we created was called voltage regulator.
Yep.
All right, so that's the value.
Okay, so what you're saying is what you hover over and select is what you end up editing.
Right.
Okay.
Okay, I think we got it. Okay, so I'm going to name the connector sensor. And you want to do this, by the way, in the schematic before you move on. Because whatever you have here is what's going to show up on your silk screen when you go further. All right? And a good example in the little wanderer was I had the component named switch. And what I really wanted on the silk screen was on-off.
Mm-hmm.
So it was better to do it at this point, because you can do it later, but you have to make sure that you not only save this, but you also have to make sure you save the updated Netlist. And it ripples through further later you do it. Okay. So now I've selected the annotation, which is this guy. And you just hit annotation, and it just, now notice everybody's a D1, or R1, R2, R3, R4. It comes from this side and works its way across. Okay? Okay, now we're actually performing a rule check. This is not too exciting because there's no failures in the rule check. So we're going to ask, so what we did was we hit the rule check button and click rule. So what we're going to do is remove a wire. Okay. Now we're going to go check the rules again. Okay, and I'm clicking off the screen up here. Now, it says I got a pin that's not connected. So will it save you from everything, like wiring something to the wrong thing? No. But will it save you on some things? Yes. this is also where those power input, power output, input output bidirectional comes into play, because the rule checker will, if I had a power source on the VCC and defined it as a power point, then if I had a chip that had a power point in that didn't have that, but I had it connected to something else, it would still find it. Yes, sir.
I was just going to ask, if you have like a chip and you're only using some of the pins on that chip, is it going to complain about the unused pin?
Okay. There it is on the sidebar. Okay, let me play that again. Just not that. We're not going to play the whole thing, but I just want to show you this. This is the don't use button. So if you had a pin that you didn't really want to use, you would go to the, like a lot of times in a microprocessor, you may not have all the pins being used. You would click this on each of the pins that you don't have.
What do you use that place a power port symbol for? The one
And this is the power port symbol
Yeah,
here.
what do you use that for?
Okay, let's say you had, if you wanted something to be a power supply, like 5 volts, you would use this, okay? And there's also another thing, that if you had multiple pages of schema that you call the power flag, which will take the power port and bring it on to the other pages. In use, we didn't need it for this, okay? But I could have gone here and put a power symbol here, call it VCC, all right? And it would now say that that is defined as being at 6 volts or 5 volts or whatever I picked, okay? I'm sorry I didn't really cover that part very well. But
so on a multi-page schematic, will it assume that Netlist's names on different pages are the same net?
I believe
If they have the
so.
same name?
I've never had to really do a multiple page. I know it has a hierarchical schema ability, but as a hobbyist, I really haven't pushed that very far. But where you do run into it is I do use a lot of connectors. So I might have 3 sensors very similar to this on the same schematic page, all right? And then I have to use the power flags basically to tell them that, you know, that they're the same thing. Okay.
Okay, because I ran across some things that I didn't really understand well.
Okay. The best way to go to that is that actually KiCAD actually has a very good help file. It really, I mean, surprisingly good. Okay, and look up power ports and power flags.
This is
Power
built into
flags.
the tool, the help file in the tool?
Yes.
Because I called up the help file in the tool and it only gave me like a 3-pager on how to install it.
It's a big PDF for each one of them. Okay. We can look at that
Okay.
later. Okay? All right. So, all right, we've looked at pretty much, and the weak part is I haven't really discussed power ports and power flags probably to what should be gone. We'll do that, but I want to keep moving. Yes.
One quick question: is there a place to go get libraries?
I've
I've been trying to follow around with you, and there's like a couple of things that aren't in my library that you've used, or like an auto
Okay,
transistor and stuff.
I'll show you, later I'll talk about 2 possible ways to go about that.
Okay.
Okay?
So John just helped me understand what my problem with the help was. I called up help on the top level program, the KiCAD launcher,
Yeah.
and that only has basic level help, but like you said, the schematic editor help is a whole different help file that has lots of stuff.
Okay.
Thank
Yeah.
you.
Yes. Okay, let's see. Okay. So, if you're, the next step that you want to do is click, this is, so this is an E schema still. And so you go up to the top line and you'll see that there's 2 icons to the other parts of the program, which are kind of the logical parts that you would use. So the next part is going to be associating parts to the footprint. So we're going to click on this guy right here. Okay, and that's going to bring up this screen right here. All right.
Excuse me, one more question about the schematic editor.
Yeah.
Can you have multiple pages open at once, and are they in separate windows?
Yes,
or?
yes, they're in separate windows.
Okay.
Yeah, and you can actually have schemas from different projects open. And there is a way to there is a way, not going over it, where you can select a group of the schematic, and you capture that. I'm trying to think of the word they use.
Sort of a drag and drop kind of.
Yeah, kind of drag and drop, but it's not a copy and paste. It's something like you copy this, and you have to use the right mouse button to copy it. Then you can actually go to a totally different sheet and do a paste type operation, and it will actually bring that into the new schematic. And it's very nice. And you can also do something like that if you want to have on the same page 5 copies of the same circuit, or similar to the same circuit. Okay. All right. So associating with parts, that we're going to import the Netlist file, and the Netlist file is the file that rules them all. Okay? So basically when you leave one program, like the one we just last, probably your last step should be to save the Netlist. Alright? And I didn't put that there, but that's really true. Now you don't really, as long as you're staying in the same project, when you associate the footprints in this part of the program, you don't really have to bring in the Netlist. It'll be brought into for you automatically. Okay. But if you've been wandering around in your directories and everything, you might have to actually go back and bring in the Netlist. All right. So we're going to do that. And for each part, we're going to select a footprint from the standard libraries. Again, because we aren't using anything really exotic. We're also going to look at the footprint viewer, so you can see how you can preview things before you do it. And then we're going to save the Netlist, because this Netlist will now have associated a footprint to all of the components. So we're ready to associate. So we're going to go up here and grab this icon, click on it, and you notice there's nothing right here. It's just a list of the parts that were in our schematic. So it has got the Netlist. Okay, so I'm going to go up here, and that's pretty easy because there's only a few LEDs. When you have an LED part, there's only a few models, a few footprints that are available for that. But when you go to the next one, which was the sensor, which is a connector, in this it's actually called a pin array. So we're going to use a 3x1 pin. Now, let's say you had a serial port. Well, you'd have to go find the serial port one. There's all different types of connectors. Now, this is one of the things people don't like about KiCAD, is you have to go through all of these things to do it. But in actuality, what you find is that after you've found the footprint that you like, you develop
a feel for where
they are, and the type of work you do tends to set it. Now, here's using the actual viewer. There is a viewer, so you can view every footprint before you commit to it. And that button, in case we missed it, I believe I want to say it's this one. Yeah. Okay. So, like here, now the resistors, I'm just using the same one. So it's just boom, 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 boom. Sometimes, okay. And then you save the Netlist, and that's actually a save. It looks like an old floppy disk. Okay, and that's it. You've now associated footprints. That easy.
Is it? And presumably each footprint symbol has a pin number that it tries to match up with the pin number on the schematic symbol?
Now, I will let you know there is actually an error in the video you just saw. If you remember the opto transistor, I just tagged it with the symbol for a LED 3mm LED. Well, on the 3mm LED, they have the anode is pin 1 and the cathode is pin 2. But on the opto transistor, the collector is pin 3 and the emitter is pin 1. Well, there's no pin 3 in the diode LED 3mm. So that will flag you as an error at the next step. Now, unbeknownst to you, Doug found that when he was making these videos, and we fixed that by actually going back into this thing and reassociating the footprint with the correct one. Okay, so you won't see that, but I'm letting you know that that's what. So the answer to you, Paul, is that if you do something that doesn't match, yes, it will. And also, like on the TO92 symbol, you'll see there, if you notice, if you watch through this thing very closely, you would notice there's about 6 or 7 different TO92 symbols. So there's a good place where you would use the editor, I mean the viewer, and you would look at each one and find the one that matched the pinout. Because some of them, the collector is called pin 3, some of them it's called pin 2, some of it's backwards and it's called pin 1, and it's just whatever you use as your symbol.
A pin number is always numeric.
It have been for me. I don't know if that's a restriction. I don't think that's a restriction. I think that's just.
But they don't use like E as a pin number or
no. Well,
like
in the transistor, generally, the E, I'm not sure where it's either defined as a label, but you can put those in your schematic symbol. Okay, and I believe you can edit them. You know, just like by hovering and hitting E. Okay? All right. So we've done 2 things now. We've went ahead and we've created the schematic, and we have associated footprints with each schematic symbol. All right. Okay. So now we're going to start laying out the PCB. But this again is the EE schema toolbar, and where we were there on this icon before, now we're going to use this icon. Okay, that's this icon right up here in the corner. And when we click on that, we're going to see this, except we won't have the board here. I just dragged an old picture with a board in it. Okay? All right, so in this we're going to do the following steps. We're going to define the first thing you do is define the board size. Okay? Then we're going to import the Netlist. That's going to bring all our components onto our page. Then we're going to, actually, this is backwards. You can do it this way, but I like to configure my layout rules before I bring in the Netlist. Okay? But there's no reason why. You can do it either way. Then, if I don't think we do this in this particular example, but if you have your personal library, you have to bring it in PCB new, just like you brought it into the PCB, the EE schema. You have to bring it in through the preference menu. Okay, show the footprint under. No, we're not going to show the footprint under. It's there. It's very simple. I'll be willing to stay afterwards and show you how it works, but I don't think I did it. Okay, you can group place the footprints. I don't think I did that in this. I think you just manually spread them apart, just to show you how they can be spread apart. And then we're going to place where they should have the minimum cross wires. That's a little intuitive. And then a real complicated PCB board. You might not want to spend a whole lot of time on this. You might just want to let the auto router sort it out, and you get a real view for where you got something badly placed in the auto router, because it'll pretty much cause you problems. And then we're going to prepare the auto router file. So let's go to layout. Layout 1 here. Okay, we're going to select a new icon, Chink, and that's okay. You often see error when you open up a window in a new project the first time. Just click through it. What it's telling you is that board or schema file doesn't exist, but it's not a problem. Okay, so did everybody? All right, I went through that pretty quick. Let me stop that and bring that back a little bit. Okay. The first part I wanted to, okay, so if you looked at this, this is a case of a chicken and egg. All right, do you create the PCB board first and then modify your part, or do you make your part the way you want it and then make the PCB board fit it? Well, that's how I did it. So, but if you look at this, this is the part the PCB board is going to attach to. It has a special window for the sensor, and it has 3 screw holes that are in specific locations. So when I make my PC board, I'm going to have to lay it out so that the sensor sticks through the hole, and I'm going to have the three screws where I want them, so I don't have to, you know, with the files and drills. So, let's see. So it turns out our bar has several special requirements. They need to be, the sensor needs to be in a special place, screws need to be specifically placed. I know that the size of the board has got to be this. Since they're all divisible by 0.25, I went and changed the user-defined grid, okay, to 0.25. This is very coarse, but what it allows me to do is to know exactly what a 1/4 inch is, because they were like this far apart, and when I drag my mouse, they fit. Okay, so now I go up to here, to the grid, and I go down to the user-defined. Now, let's see. I was hoping you could see them. You might not be able to see. There's little white yellow dots here somewhere. Okay, now we're going to use the dimension. Okay, maybe we're not there yet. So we now use PCB edge level to define the edge. And I'm going 1 dot, 2 dot, 3 dot, 4 dot, 5 dot. Then I click 3 dots down. Click, 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 click. That's 1.25 inches, and then back up in the end. Okay, now you see how it's got like little openings there? That's the case of the ziggies I told you. And watch what happens when I hit F3. You're gonna hit me. I'm going to hit F3 here in a minute. Okay, and it fixed itself. All right. So now I'm going to go to the drawing level. Okay, and I'm going to go to the dimensions button, and I click. Oh, I screwed up there. Click. Come on. Come on, Doug. Oh, there he goes. Then he's clicked again and he pulls it out and it's got a dimension. Click. And so now I have the dimensions on my board. Okay? All right, so at this point you've laid out the shape of the board. All right? Okay, now I've changed it around because I've put out all those dimensions for where I wanted the sensors and where I wanted that. And I used the top silk screen to create little circles using the circle to put where I wanted them. Okay? So I used this top silk screen to place where I'm going to put the screws and where I'm going to put the sensors. And then I made sure by using the dimensional tool that they're all there. Okay, now this is changing the design rules. So I'm changing the minimum clearance to 20 mils and the track width to 20 mils. Originally it was 10 and 8. Okay, now I went to the other side, and I'm creating additional options for either vias or track lengths. Okay, I'm not going to actually create any, but usually on a project I would, for the power leads, I'd create track leads that are wider and whatnot. Okay. So here you can see the dimensions. I'm going to bring it up to. This is what I'm going to do. Okay, I'm going to do it to 5. That's probably a good one to start with. And then I'm going to read the current net list. And then you see this big pile of parts that just suddenly popped up over here in the corner? That's all the parts in our schematic down there.
Just in a pile, aren't they?
Just in a pile. Now, like I say, there is a button up here called Auto Place that you can use. And it will spread them out for you automatically. And that's not a bad tool, but it's, for something this simple, it's just do it. I'm going to show you how to do it manually. So I'm just moving the screen around. There's the pile of parts. And now, when you click, if you're on top of multiple things, it'll give you a little window, and you can select what you pick. So like here, there were a couple of parts. Let's see if I can get it to pop open again. And I'm just spreading out the parts.
Was there something special you had to do to get the rat's nest to show?
This button right here is rat nest, but I believe it's defaulted on. You see, when I on top of two things, I had all of those things I could choose from. So I picked the R1 resistor. And that way, if things are stacked on top, you get a choice of which one you pick on. Okay, so all I've done at this point is just, all I did was spread them all out. No, nothing intelligent about it, just spread them out. All right. Now, we're going to jump ahead a little bit. They're all going to be in the right spot.
So you would have used the rotate and the move commands to
Right,
move them
rotate
around
and
until the rat's nests were most directly connected as far as you could see.
Exactly.
Okay.
Okay. We want to cover. Okay, so here they are. How's that?
Magic.
These were things I think they're good. Now you remember I have to have some space around here because I'm going to have a little thing that fits on the front of it. Okay, so, all right, so now all I'm doing is clicking this last button which gives me access. And we click on this. And I've exported this DSN file. And I'm opening up the free router. This is what you see there. And I'm going to open up my own design and click on this. After you've done this one time, it will look in the right directory. Okay?
We'll look from the left.
Yeah. The last directory, okay, yeah. Since it's usually
Not that smart.
Yeah.
Knows where you want it.
Okay. Okay, and I think I finally found it. There's the DSNM file. Did you all see that? Yeah. And here's what it kind of looks like spread all over. Okay. And I think I actually sized the window, but it's not, doesn't size very nicely to this. So, in fact, you can see, here's the toolbars for it. This is what it looks like. And I'm just kind of like scrolling through and letting you see how it looks on the page. But now, let's see what I do with it.
The board, huh?
Somewhere there's a little thumb drive. Does anybody see
Yeah.
it? Oh, okay. All right. Who wants to go do the auto router?
Sure.
You've got your computers open. I have a DSN file in here. Just throw it to your desktop. And then we'll open up a web thing, and we'll go to that website, and you can all auto route yourself. Okay. All right. Now let me. The only problem is it's probably hidden in there. You'll have to find it. Oh. Okay. If you've got KiCAD open, then you just have to open to this file and then click on that last icon, and it will open up the auto router for you. Can you bring it up to the front too when you get find it?
Yeah. It's under
Probably tutorial.
KiCAD tutorial.
Yeah. And it should be a DSM file.
Okay, example 1.dsn.
Yeah.
So I'll bring that up onto the top layer.
Yeah.
And example 1.dsn. Move that over to desktop. And then someone else. Does anyone else want to?
If you feel queasy about putting this into your computer, it is virus free, but
Okay, so now
I can understand that.
Auto route it. Open up.
Go to the last icon. Oh wait a minute, this is not. You gotta bring in that file.
Should I make a new one?
No. I think try this. Yeah, go to a new directory, a new project. Just
New board.
new board, yeah. That just says it doesn't exist. Okay, now go out to this icon. Okay, no. You want to, you want to launch the
free router?
Yeah, launch the free router. Okay. And when it gives you the little thing up in the corner, go. I think you have to import the. I think you have to import it. Should be on the top level now. I'll put it there.
Okay, what we're looking for now?
It's a DSN file. It should be example_1 DSN. You see it?
Oh, there.
Yeah. This person.
Okay, was something need to pop up?
Okay. Open up this.
Here it is.
Open up this link. If you have the file in this link, that's another way to get to that auto router. It's called free routing instead of free router, but when you open up the application, it's called free router, and in some places it's called free route. So I'm not exactly sure what the name of it is, but I think it's called free router. Anybody get it up?
Yeah.
I think it's still working because Java came up and did somebody.
Really have problems with Windows 7, it's the way they do things. And we can get quite... Keeps trying to force those libraries on you. Okay. I'm just using my own key.
What program do you open that file in?
Hmm?
Which program do you open that file with?
Okay, so let's I can hit this last button, export, okay, save, okay, launch the free router.
That's what I didn't do. I didn't do the export.
Well, you shouldn't have to because you had the file. The reason I just did that because it was faster than copying the file over. Okay, now I should have a little, should be, oh, there it is. Okay, open your own design. Okay with that. this. Upload that. That's the file. It takes apparently pretty slow here. At home, this is real snappy. There it is. All right. So, okay. There's a couple of things you want to do when you're in the auto router. Remember, there was a while we tested the. We went back and we tested the. We changed the design list. You remember we did that, okay? They should be reflected in what you see on the auto router. So you go up to rules, and there's two places that you have to look. One is the clearance matrix, is where the clearances are defined. And what I'm looking for is that 20 that I put in the other. It's 20.2, but that's some sort of weird round off there. Okay, so that one did go in with no problem. Okay. Then the next thing you check on the rules is the nets or necklaces. I think it's on that. No, it's not. Let's be necklaces. Okay, and here you see the trace width is 20, which is again what we set before. So the rules that we had, so what happens if you don't change the rules before you come here? Well, you can change them in here, okay, but it's harder to do than it is in KiCAD.
Would you lose it then? I mean, so it's
It
not
doesn't go
permanent,
back.
This is web-based.
Well, yeah, this is web-based, so if you come back and reroute, and that's one of the things I'm going to tell you, is that a lot of times you don't accept the first solution from the auto router, so you'd have to come back and put them back in, and it's just not something you want to do. All right, so the next thing you want to do is you want to go to the parameters. And on parameters, the one we're interested in is the auto route. All right, so the first thing we can do, simple, is we can just say, I don't want anything on the front page, on the front. This should not work, okay? But I'm going to try it. So then I go over here to the auto router, and I hit auto route, and it goes. Then again, it might work. Okay, there is a solution for our circuit, ready to rock.
One side.
Hmm?
So it's just one-sided.
Just one-sided. And I'm a little surprised by that. Okay, all right, so I guess for the second time I did this project, I must have moved something better. All right, but, okay, but let's see what happens. Let's just play with it a little bit. So I don't like that.
Okay, so it was successful in getting it all right?
Right, it completed. Okay, now you can go look at
Is this
incompletes.
the same DSN you passed out?
Yeah, you can. Okay, now there is a violation. There's a clearance violation right there. Okay? So there are two clearance violations. Now, getting this particular solution, now what I would do at this point probably is I would probably go back to my other file and move that component up a little bit and come back and do it and see if I cleared that thing. All right? Because what that's really telling me is the component is too close to the edge. It's not telling me that it had a wiring problem. It told me that the component was too close to the edge.
If you didn't have a restriction on where you put the board, you can make the board a little wider.
Yeah, you can make the board a little wider. All right. And that would actually, in this case, not be a problem. All right. So now I don't like, I'm not going to bring this back, but I could bring it back. If I bring it back, well, we're now 68 minutes. Okay, I hear. Okay, I think we can. Let's go ahead and pretend that this worked. Okay, but before we do this, I'm going to undo this, and I'm going to show you what's more likely to happen. Okay, you go into the parameter, you go to auto route, you do open this, and then you go to the detail parameters. And what you do is you click on those, and you want it to favor the back. So on the weights, you can change this. And there is a quirk here, you always have to hit enter after you make a change. And then I'd probably bring this guy up to 5. And then this guy to 5. And I will tell you that by messing with these guys up here, I have gotten different solutions, some better than others, but it's more of a little bit of a feel at this point. But you can do this as many times as you want. All right, you can always hit the undo and roll the dice again. And then, like I say, another thing that'll happen is you'll get a solution, and you can see the way it's laid out. You can see that if I move this component just a little bit another way, I'd get a better solution. You can act, or otherwise it will help you pinpoint bad placement. And you say, well, give me some enlightenment. Well, there's no enlightenment. You just kind of got to work through it. And it's not very hard. Those cases will show up. All right, so here what I've done is I said, yes, you can route to the front, but I really prefer you to route to the back. Okay? Should close that. And then I hit my auto router again. And it gave me the same solution. And the reason it gave me the same solution was because
You could do it.
You didn't move, it could do it that way, and you didn't move it that way.
All right, but okay, so all right, so let's go ahead and so what would you do next?
Can you do like partial rip up and replace manual routes kinds of things?
I don't know. Yeah, there's some. You see this route and drag. There is some capability for you to do some things, but most of the boards that I deal with, which are fairly simple, I just don't. Every time I've done that, I've found it harder than to just hit the undo and go back to KiCAD, move apart a little bit, and go that way. Okay. All right. Where were we? Okay. So we're going to say, well, what would you do next? Well, you export this to here. And you see it tries to put it here. Now this is another thing that it doesn't do, is it doesn't put the extension down. So it's an SES file. Okay. And you save that. And you have the option. So here's a case where if I wanted to go back to here, I can do that. All right. So at that point, we're not really. So now I'm going to back import the SES file. That's the third button.
Did you click to get that menu? What did you click to get that menu?
This menu?
Yes.
This is this last icon. You don't, otherwise when you click this icon, you leave this window open until you're finished. Because if you close this, it essentially closes the auto router.
What are those things, just changing topic for a minute, what look like tabs, but maybe they're drop-down buttons across the top? What are those?
Those, remember I defined, let's see, I guess I don't have them right here. If I had gone up to the rules, let me get rid of this now. Okay, I don't need this anymore, so I'm going to close this. All right, if I go up here to the design rules, and go up here, and I go to the global design rules and created additional options. Okay, this is not a good one. say I did 0.07. Okay, and let's say I wanted a 0.05. Okay, I could create, you know, maybe a 0.04. Okay, or maybe I wanted some. I wanted 30 mils. Okay, or 40 mils as track width options. I could create them in this page and hit OK.
Got a 400 track mill there.
Yeah. 0.04. It probably doesn't like this. It's like it's in somewhere. It's like it's in metric.
I'm sorry, I didn't mean to take you like way off track.
Well,
it's okay.
no, I think it's in metric, and I think that's the problem. And I'm not used to metric, and there must be a metric. There must be a metric
Millimeters,
SAE
something like that.
setting somewhere. All right, but what I want to show you is, you know,
You hit cancel instead of.
yeah, cancel. Otherwise, if I had created different ones, up here, there would be, okay, you can see there's different vias. All right, so if all of those that I had created had stuck because they were not metric but actually English, there would have been a whole list here. Likewise, if I'd have gone to the track side, there would have been a list of 20 mil, 30 mil, 40 mil. And that way I can change the track width on the fly as I'm laying it out. And so, well, how would I do that? Well, you can right-click on it. There are segments and there are tracks. A segment is a part of a track. So you can either change the segment width or you can change the track width. You can delete the track. You can break the track. You can drag the segment. That's another nice handy key. It's the G key. Okay, you can use that sometimes to move something. Just nudge it a little bit. All right. So let's see. So there's our wiring. It's ready to rock. So the next step, and I think, so everybody sees the wiring, okay? All right. Now, see this right here? See this circle? That's my clearance circle. Do you see how it's touching the edge of the board?
Mm-hmm.
That's where I got the violation. Okay. Now, you remember we used in the schematics, we went in, we named something VCC and ground. You see this wire is named ground. See, there's that anode that we named.
Yep.
There's VCC. Well, what about this? Well, what's this one? If you, I don't have a 3-button mouse, so I'm not really sure. I think a double click, but I'm not sure. But if you expand this up higher, what you will see is that even the wires that you didn't name have a Netlist name. They're just something like N463223, which is not very intuitive. Okay? All right. So, all right, I got a PC board. Now, one of the things that after I've done the auto routing, I would often go in and put a via in the middle of these on the back side of the copper, so that when I drilled the PC board, it would be easier for me to drill.
Because those won't show up as any copper.
Yeah, these are just on the top side. They were just there for me to know where they are. And so I wouldn't put components on top of them. Let's see. Let's go back to PowerPoint. All right, so this free router can be used in all of these different programs. Here's, I believe, the interface that it's using. It's this button on the end, and this is the little window that we saw before. Okay? Now,
Question on the routing.
we didn't do this because, huh?
If you had a wide route, okay, like really high power, what does it do on the corners? Does it miter them, round them, keep
You
the
have,
square, or what?
you have, I know there is, in KiCAD, there's some options for that.
Okay.
All right, and there is also some options, I believe, in the auto router too. Okay. The defaults have been generally good for me. Now, one of the things that you will find in KiCAD that sometimes you run into, how do I make this? Is, let's say I wanted to route here and I'm slightly off grid. This is where grid comes into play. If this location isn't actually a grid point, and I'm trying to route to a point that's not a grid point, KiCAD won't draw the lines. And it's not just KiCAD, most programs won't do it. But I'm just saying, so if you keep going to this place and it just doesn't seem to ever stick, then what your problem is you're off grid. So you might want to move your component just a little bit to get it on grid. And it probably, and how it got off grid was you changed the grid sometime in the past between when you did the placements. All right. Okay, this is basically what we did on the screen without, and the reason I didn't make a video of that was because when I made a video, there's no way I could size the window to actually fit in the little program I was using to make the videos. All right, now, okay, so if you're fine-tuning, here's some rules. If your auto-routing returns only a few lines on the front side copper level, try to find ways to turn them into 2 vias and a jumper. Okay, and that just means that, so like, if a wire goes from this node to this node, you delete that wire, go to your backside copper, pick up here, and you go to a location, you create a via, and via happens to be V. Oh, it's clever. And then that'll automatically drop you to the top level, and you can trace over to where you want to go, create another via, and it'll drop down to the back level, and then you go to the component that you had the other side of the connection.
That's when you're routing the wire?
Yes. Otherwise, so you got this wire that's all green, all backside, except for one red, and you want to get rid of it because you could make a one-sided board if you didn't have that one red wire. So like I say, as you delete the red wire, you'll then get, what do they call that, the rat's nest. You'll get a rat nest line. So you go to one end of the rat nest line, where the one connection, you change your level to the backside copper, you click, you drag your trace to a place that's where you're going to want to do the jumper. You hit V, you'll create a via there, and you'll notice that it also changes the level automatically to the front level. You go over to make your crossover over the green line that you were trying to get around. You hit another via, and it will place a via there. You got to be careful of your clearances. You have to have clearances. But then once you're on the back, it'll automatically change it to the back side. Then you connect the other side.
And then you just don't put the copper on that side.
That's right. And then you just don't actually. You'll still see a red line, but you'll just ignore it. You'll just go from via to via. Okay, don't take the first auto-routing solution unless it works. We'll find that by messing with those auto-router parameters, you can actually get some quite different answers, and some of them, I've sat, where late at night and I had nothing else to do. And I'm sitting there and I'm clicking on this board, and I'm getting four jumpers. I move a little placement. Got 3 jumpers. I can't see anything else, and I run it again. Run it again. Now I'm changing those parameters a little bit, the weights and stuff. And all of a sudden, boom! 1 jumper. And why? Something in the program. You probably have a random generator to start it off. Hit right. Okay? All right. Now, I'm going to show you this. I'm not going to show you a video, but I'm going to show you an important thing. So let's say you auto-routed, you imported the file, and then you said, you know, that's just not right. I can do better than that, and I really want to get rid of all those wires. How would I get rid of all those wires? Because I just ported all these wires. It's all wired on. Am I going to go through them and get rid of each one of them? No, I'm not going to do that. I'll show you how to do that. So, okay, so what you do is you grab this, whatever this is called, the group or whatever, okay, and it pops this up, and then you disconnect all of these buttons. You're not going to include the modules, not even going to include the zones, I'm not going to include the text, I'm not going to include the drawings, I'm not going to include this, I'm not going to include it, I'm only going to include the tracks. Hit OK, right click, delete block, call it a block. And all the wires are gone. Now I can go back to the auto router and do it again. That's very kind of one of those aha moments that I had. Okay? So, going back to the PowerPoint. Okay, now, how do we actually plot the back side and the front side? Okay? You can go, oops. Okay, we can, let's
Can you just do the undo?
That's a good question. I bet you can. Okay. All right. So you can do the undo. You got these guys.
Yet another aha moment.
Yeah. So now you hit, and I think you will find this. This program is good enough now. It's evolved enough that there is some depth and layers into it. The more you use it, you'll start to see little shortcuts that help you. Okay, so you go to File and drop down to Plot. Okay, and we don't want the top side level. We only want the black. It's best to do this one level at a time.
You unclick the front side there in the corner. Came back.
Okay.
There.
Okay, and I'm going to do it in PostScript. I'm going to leave the scale at 1. And I'm going to plot that. And I hit plot. Okay? And when I hit plot, it's going to go give me a message saying it created the file. Then I'm going to come back in, I'm going to uncheck this guy, and I'm going to hit the front screen. And because I'm doing a toner transfer method, I'm not doing a true silk screen, I'm doing a toner transfer method. I have to mirror this. Okay? And then I'm going to hit plot. And it created that. And those are the two files that you're going to use in either Photoshop or GIMP to actually go down to Staples and create your PC board. Okay. Now, the instructions for that are actually here. So if you didn't follow that, here they are. Okay?
Now, you can just put those to your laser printer, right? You're saying
if your laser printer has able to hot PostScript, yes, you can. Okay. But most printers now I don't think can handle PostScript. I don't think most of that's done now through programs. I don't know. For me, what I do with my HP or Brother inkjets is I put them in, I happen to have Photoshop, so I put them in Photoshop. I create a whole page of them, and I think that was covered in February. Yeah, February meeting. And shows you how to, and then I just go down to Staples and have them, because I don't have a laser printer. But if you have a laser printer, you just make the font page with all the different patterns, run it through your laser printer, and you're ready to rock.
Okay.
Okay? All
So
right.
is the purpose of using Photoshop to do that replication and then output it in a form that can be recognized down at Kinko's?
Actually, I think it's more, yeah, the arraying, I use the Photoshop to do the arraying, but the other thing that's happening is I'm converting a PS file, a PostScript file to whatever comes out of.
JPEG or something?
No, actually, I think I keep it in native Photoshop.
Oh, PSD?
Yeah, and then that way I just hit print, and it prints out.
Okay.
You could, on the silk screen side, you could add graphics, you said it was more primitive.
Yeah, once you're in Photoshop, you can do anything, and that's what I'm saying is it's probably a better way to do it than to do it using the little tool that's built into KiCAD. But it's kind of cool. It's just probably, and if you were doing Gerber files, it probably would be more useful. All right, now, okay, I'm going to go quickly here. Guys, we're almost finished. Stick with me just a little bit longer. I want you to see these. Okay, quick library application. Remember I told you that there it is. You can create your own part. So how would you do that? Remember that part we created? We created a voltage regulator. Remember that part? I could come up here and hit 3. Okay. And sign pins. And I could call this, I believe pin 1 was ground. Pin 2 was input. And pin 3 was output. And if you remember this one was like the ground pin was, the ground pin was like that. And the output was, that looks good. And you have to know what these symbols are, and I don't know if it has tooltips or not. Oh, no, that's the style. Here's the type, okay? So in our case, we were going to have, the ground was going to be a power input, and the input was going to be a power input, and the output was going to be a power output. Okay, now we can preview that.
So this is online. This is
Yeah.
web-based.
And actually, when you do the library, it'll actually look exactly like what we did. For some reason, the preview puts the value and the reference this way, but when you actually export it to your library, it actually moves them in a more normal position. All right, so kind of cool.
Okay, so that's just basically a web application?
Yes, it's a web application, and it will export to your computer the library file with the part in it, and you can actually build additional libraries. Having done some MSP 430 parts online, not online, but manually through KiCAD, I thought it was very easy to do, but this is even easier. So, worth knowing. This is the location of an Eagle to KiCAD library thing. I haven't actually used it, but I have seen it mentioned a lot on the web and everything. This is converted Eagle libraries. There's just kabuki's of them, and you know, you can bring them all down. Their lib is a library. Mod is module, which is actually what we're calling footprints. components, I don't remember what they're called. They're probably in the lib. All right, so this is a contributor from Japan, I think, who has, he's even, by the way, one thing we did not cover in KiCAD is that you can actually get a 3D view of your board. That's pretty cool. And here is a beautiful selection of different libraries he's got, that he's done. And we'll get down to the pretty stuff here. There's his 3D models that you can import. Different connectors. So I'm just saying is, there are resources out on the web. These are the help files, like I said, they're written by somebody in France, and so there's sometimes the logic is a little strange, but they're very, very good files. And then I actually found this Curious Inventor to be a good guide, and then the KiCAD organization actually has their own, which is a little more nerdy, but you'll get you there. Okay, so hopefully 95 minutes and 10 seconds later, you now know how KiCAD is organized. You have a typical project process flow. You should be able to try your own project. You have this presentation and videos as reference material. Should be able to read through the tutorials online with confidence. All right, now my challenge to you, because often something like this is you say, ah, that's cool, I remember reading that 6 months ago, I didn't do diddly with it, and I don't remember anything, and I remember the name of the program, that's all I remember. Okay, what I would suggest to you, this is a very simple thing, and the number total of parts, if you bought them, is 92 cents. Go get yourself four 2N 2222s, 4 2Ns 2709s, 4 diodes, probably a 1N 914, 2 1K resistors, and 1.1 microfarad capacitor, non-polarized. And make yourself a little H bridge. Got to stay with the robot thing here. And for people who aren't familiar with that circuit, it's going to be something like this. And then you go into your PMPs.
So you're in effect making your own Darlingtons.
Go to the web.
Yeah.
They can do it.
Darlington.
Yeah, it's 2 Darlington pairs, and the two. There's an NPN on the top, EMP on the bottom, and you connect the 2 inputs together, and then throw them through a resistor. You just look at H bridge on the web. Okay, and like I say, everything that's here is on a standard library, so you don't have to create any new parts. You should be able to do everything cool. And go ahead and play with it. See what you can do. It'd be, I think you really will enjoy this program. All right, and I think that's it. Yep, that's it. Cool. So 97 minutes and 53 seconds later.
Thank you, Doug.
Any questions?